Good afternoon, ladies and gentlemen. Welcome back to our third webinar in a series of 6 that iTAC is holding. Today we will be looking at our theme, which is the IIoT, or Industrial Internet of Things, and how data analytics and artificial intelligence are used in the production environment. My name is Martin Strempel. I'm a business development manager at iTAC, and I'm responsible for the data analytics and business intelligence part of the presentation. And next to me today, I have my colleague Jörg. Jörg.
Yeah, thank you very much, Martin. Hello and herzlich willkommen. My name is Jörg Both. I'm the sales application engineer with Kochiscan.
So before we start today, I would maybe just like to look at the agenda, just also remind everybody of also the webinars that are coming up. So after today, on the 22nd of March, we'll actually be looking at closed loop, which is an interesting field where we're taking simulation, we're taking APS, which is your planning software, and we're taking the MES and MOM data, and we're looking at how these in together and combination with each other will actually drive us to new production efficiencies in the future. Then on the 26th of April, the next webinar looks at the medtech industry. We know that a lot of the industry in this area is still very paper-driven, paper-based. So we will look at some of the challenges at implementing your MES system and your MOM system in that environment. And then finally, on the 21st of June, we will be looking at flexible production. We all know that the actual conveyor belt, as we know it, a form of traditional production, or that almost iconic image of the traditional production line, is disappearing. We have flexible production with moving robots that are transporting different items around. And obviously this brings with it a whole new set of complexity that needs to be looked at, especially how does your transport and logistics actually tie into your MES and MOM system in the future. So we look forward to you joining us at those webinars too. Maybe for today, I will then just start with the agenda. So we're busy with the welcoming notes now, but in the next step, we will take you through the concept of an IIoT factory, or the smart factory, and what this means in the future and why it's such a hotly debated topic. After that, we'll look at some of the strategic challenges that face all of us when we talk about implementing artificial intelligence in production. And finally, we'll look at some of the solutions that are available, make that journey easier in all of the different organizations. Finally, in terms of the we will also have a Q&A session at the end of the day. So we do invite everybody to send their questions to us. We will have a look at the end of our presentation today. We'll have a look at the questions, and we'll try to answer as many of these questions as possible, and look forward to hearing some feedback. So then, Jörg, maybe you can tell us a little bit about the smart factory.
Thank you very much, Martin. Dear viewers, first of all, I would like, before we talking about the smart factory and the paradigm shift, I would like to comment on this shown note or quote. So the factory of the future will have only 2 employees, a man and a dog. So the man will be there to feed the dog, and the dog will be there to keep the man touching from the machine or the equipment. So right, so this means this refers actually also to the idea talking about the lights out of manufacturing.
Lights out factory.
Right. So meaning using that method of a fully automated factory environment for higher throughput and higher efficiency.
Yeah. So maybe a long-term goal for everybody viewing today, right? Yeah.
Right. Yes. And what does it mean, the paradigm shift in our daily life, or especially in the future? So using available AI solution for increasing the productivity. So what does it mean in terms of implementing such a paradigm shift in our factory environment? Is first of all, reducing the time to implement. So using new innovation, new technology in our factory environment, and reducing the time to implement.
Specifically also looking at how artificial intelligence can help with those tasks.
Right. And indeed, the next subject that needs to be considered as well is lower the production risk. So applying AI solution also means lowering the production risk and securing the production output. Yeah. And finally, we talk about maximizing the flexibility is another considerable subject that we have to take in place.
Also one that I think is really relevant these days, right? We all know the challenges some of the logistic chains and networks have had in the last couple of years, well, specifically since after COVID. I think flexibility is something that is on everybody's mind at the moment.
Yes, absolutely. Yeah.
I also think interesting, maybe just to add on that, what you've said is all of these are also very much about reducing cost in your production line. So each one of these obviously have a cost factor that is attached to them. And in total, Wilson's looking at actually making manufacturing more affordable, right?
Yes, right.
So this brings us to the next slide, and I think that is possibly also the fear that everybody has, right? AI will be ubiquitous with the factory of the future, right? That means we think that there will virtually not be a single system in your production line in future that does not have AI integrated to some degree, be it less or more, in your factory. And that in its own sort of makes one feel like one has to get started with this journey, right? You don't want to get left behind, and you for sure want to make sure that you're not left out in the cold and then you become uncompetitive because you haven't actually embraced AI as fully as you should, or even worse, as much as some of your competition might have done. And I think there we can draw analogies with what we've seen in our personal lives, right? There's, I would say, I mean, compared to maybe 10, 15 years ago, there's not a single device at home that is not using AI in some manner or form at home. At this point, it might be a good idea just for me to also explain a little bit more what we mean with AI. So artificial intelligence is a new way of programming, a new concept where we don't actually necessarily code in explicit code lines and loops and routines anymore, but rather we've taught software that how to learn and extrapolate information from data that we provide to it, right? And like I mentioned, we're seeing it in our everyday life, but I think some examples that are very tangible for us just to get an idea. We know that when we're taking photos these days on our cameras or our smartphones, we see the pictures, but we also see that the camera also automatically recognizes the faces, can even detect if you're smiling or not, and use that to trigger the camera and the shutter. That is AI running in the background that's enabled us to do that, right? And a second example might be your voice recognition. If you've got it in your car, like I know there's the commands like, hey Mercedes or hey BMW, or at home, your Siri commands, or these are further examples of how AI is benefiting us, maybe in our personal lives. And I think it's interesting, right? Because these are problems that we previously thought only human intelligence would already be able to solve. But now we're seeing with this AI technology and this new way of programming, we're solving problems that we never thought actually 25 years ago we could solve with software, or at least we thought it was a huge, huge challenge and might never be viable, right? So maybe we can then make it a bit more concrete for our viewers, Jörg.
Yes, right. Thanks for the insights of these examples that facing our daily life. But what does it mean in implementing AI solution in a daily business, especially in the electronic manufacturing environment, for example? So when we start with the reactive or the erection, so everyone knows at home and has already faced that issue that the light bulb suddenly breaks. Mm-hmm. So a few seconds ago, it was still bright in the kitchen, but suddenly the light bulb breaks and immediately it's going dark. And so, unfortunately, when you're lucky, you have a replacement part, right? So it's
or as it would be in my case, so I realize that I'm going to be sitting in the dark for the rest of the evening, right?
Yeah. So so from reactive to preventive. So the next step further. And also another example of our daily life is we are all sitting in a car together with our loved ones, with our families, and preparing for the car ride to get to our vacation spot. And you don't want that the car breaks in the middle of the road, right?
That's your most precious cargo, right?
Yeah,
that you can have.
Especially me, I'm always very concerned, and before the car breaks, I'm actually bringing my car into the garage for a checkup, for an inspection, and making sure that everything works fine. And this is kind of a preventive measurements or actions that we are considering.
Yeah, it's a very good comparison to what actually happens in industry at the moment. So the first one, right, when we're talking about the light bulb, obviously that's not acceptable for production, right? If you figure out your machine breaks down and then you're going to wait 3 months for parts, right, that would cost millions, and who knows if your company would even survive that, right? The preventative method is the only approach you really have at that point to try and have any control over it. Make sure that you've got light bulbs stocked in the cupboard, but also make sure that you regularly change them, or in this case, as you mentioned with the brakes, make sure you service your brakes before you go on holiday so that you get there safely. With the next step, we're talking about actually going into this predictive context, right? Using the information that we're getting from all of our machines and the data to actually make a prediction. And I guess it's kind of like what happens maybe when I go home tonight, it'll be what Netflix is going to tell me what I should be watching, right? But in terms of the factory, it is using this information to actually schedule when your machines, for example, should be serviced so that you can actually optimize that. Why? Because just preventively servicing your brakes every time you go on holiday, you might still be actually able to travel 3,000, 4,000 kilometers on those brakes, right? Now you're being cautious, so you have to do it earlier. But you might want to, if you could actually know exactly when they're going to fail and you can get there and back safely, you would actually go on holiday without having to service your car. And that's very much that paradigm that we're talking about when we talk predictive maintenance, right? Using the data we have to find that optimum point where we can service our machines. And if we look at it in the bigger context, there's a lot more to it, right? Because now, even with your car in future, your car might actually automatically schedule itself to go and actually be serviced, right? The same is already happening in industry, right? We know that the machine has maybe 3 or 4 shifts to go, and it's finding the optimum time when it can actually then be serviced, sending out all of the warnings to the maintenance crews that this is going to happen. And if you have it linked in, or at least in future have it linked with all of your scheduling software, it'll find the exact optimum point at which that needs to happen so that you can actually, again, gain efficiencies through all of these multiplication factors through your production.
Yeah, thank you, Marty. We just heard about real life examples applying these consideration into measurement, right? But let's use these consideration in our factory environment. For this specific use case, we have identified a real-life example of an automated optical inspection machine, which is used and run in an electronic manufacturing environment. And the main problem here is that the AOI machine creates so many false calls that affects the high level of manual verification which is needed.
So maybe just for our viewers, just so I think the optical inspection unit is normally something that we insert after the main process, right, for example. And it's a machine that in this case, I think most of them are optically based, right, but they will verify that there's no defects with the product. So,
Yeah, that's right. So from the quality standpoint and perspective, the automated optical inspection machine is securing the quality process on your product.
So you want to make sure that there's no defects going through, or at least that you know of the defects that have potentially happened up to that point.
Yes, that's right. Yeah. And considering all these problems, that creates a high level of manual verification requirements and efforts. And consequently, it lowers the cycle times.
So that means these machines sometimes identify errors that aren't real errors. And we then have to go into the system manually, adjust it, make sure that it actually can be passed. And there again, we're using human intelligence to verify the problem. And what we're saying here is, with this use case, maybe we can do it more cleverly, right? Maybe we can use some sort of algorithm, some sort of artificial intelligence to actually verify if these false calls, as you called them, can be cleared.
Yes, indeed. And there is a solution out there to use a trained AI algorithm on your product and inspection measurement, and to filter out and screening out these false calls, and optimizing the operation, optimizing the inspection program that we can feed back to the machine, and therefore we can consequently optimizing the entire operation.
Yeah, I think we've prepared a demo for our viewers just to also show this, right?
Right. We have prepared a demo that you're going to see now. So therefore, we have prepared a demo. We log into the iTAC IoT Edge cockpit. On the left-hand side, we see predefined AOI use cases that we can select. And so let's select our AOI use case in this case. On the right-hand side, we see an event list there where we can see all coming events from the AOI inspection machine to that platform. And therefore, we have the ability to analyze each event in detail with the timestamp and with the actual measurement data.
So I see also that they seem to be coming in quite regularly, about every 10 seconds. There would obviously be then an event in line with the takt time of the machine, right?
Yes, that's correct, yes. On the lower side, we see every event or every measurement classified and identified with the IoT Edge platform. So it takes every measurement in analysis and decides based on my classification and confidence threshold, the system detects the measurement either as false call or real errors.
So we're taking the measurements that we got out of the AOI, running them through this algorithm, reinterpreting them, and then attaching a confidence interval with it about how certain we are that that's a pseudo error or that that's actually a real error, which I'd assume that in that case we want the operator then to actually investigate that one properly.
Yes, that's correct. And in addition to that, we have the ability to see every measurement in our rework station viewer. So every measurement or every classification by that platform is colored either by yellow, that means it's a false call, or red is it's actually a real error.
Okay. And then that threshold you were talking about, you can use that then, I suppose, even to automatically clear the errors. If you confident that it's a false call, then you can actually get the system to clear that automatically and save some time. And I suppose that is really what one is trying to implement with the use case.
Yes, this is up to the operator's decision to make the final classification based on the analysis. And the upper left corner, we see in historical diagram where we can view all the past measurement analysis or results in terms of the false call and error call. And
okay, so
errors.
This would be to see trends in how your or your system or your algorithms also behaving at identifying these pseudo errors or the real errors.
Yes, it takes place over a specific period of time, and we can also see that obviously there was no production scheduled in this time period. That means no events came into the platform.
That makes sense. I see we're there between midnight and 8 in the morning.
Yes.
So, okay. So.
Yeah, to summarize the AOI false call reduction use case. So basically what we do here is we're taking the inspection measurement data from the AOI machine, feeding it into the IoT platform, applying pre-trained AI algorithm to screen out all these false calls and to optimize the inspection program.
Yeah, that's correct, right? So I think there's also the slide just for everybody, just showing exactly what we just described. We're really just taking that data, reinterpreting it, and using that in the next step.
Right. So, dear viewers, we would like to do a hard cut here. As mentioned in the beginning, Martin announced a survey that we would like to invite you to participate. And we were wondering whether you have already started your IoT journey in your factory. So please, join the survey and send your feedback to us. And we are wondering and very curious to know about the results and which we will talk about it later.
Okay. Yeah, we would be very interested, like Jörg mentioned, to understand. So what we've done is we've actually got some statistics from industry, and it will be also for me, and I think for us, but also for you, very interesting to see how our viewers actually align with with the statistics that we've seen, at least in the past, and we can verify ourselves, and these statistics from various sources outside that actually show a shocking statistic, and that is that essentially only 1 out of 10 AI projects are actually successful, or if you want to phrase it in the negative, 9 out of those projects are failing. And that is a bit of a, I don't know, a warning sign, or something where you actually, I think one has to pay attention to when one is starting to look at AI projects in your environment. And I think more accurately, what I might want to ask actually, or rephrase the question is, how do I make sure that whatever these problems are, I can avoid them when I am actually on that roadmap myself? And 2 things stand out for me on this figure, on this picture, right? The first is the number of not in use cases, which is in this case 7.3 according to Forbes. And that is a relatively low figure, right? So for me, that tells me that everyone's understood that artificial intelligence and using it in production is key, and one has to investigate it, right? Everybody's already underway and looking at how they can benefit from such projects in their production facilities. The other figure that I see in this case is really the 14.6% at the top, which is the number of projects that have actually gone into widespread production. And this is something that I can attest to too, in my experience working in this field now for 10, 12 years. The jump from actually having something that works in an isolated case, or maybe in one or 2 areas, to something that works across generically in multiple variants is a huge step that needs to be taken. And I think we will discuss some of the key things that we've identified as challenges that, if one addresses them early on, actually help smooth this progress and actually help you transition from limited to production into widespread production. So.
Yeah, interesting. Thanks a lot, Martin, for these interesting and unfortunately shocking figures. What does it mean in terms of challenges implementing such IoT solution in a factory environment? What about the data connectivity? Martin, maybe you can give us...
I have another set of shocking statistics there, right? That is 80 to 85% of the machines that we're talking in your average production facility are not connected at all. That means either manual file verification or somebody actually manually transferring data over at this point, still to this day, or we're just ignoring the data, we're not using it. So this tells me a key element that one needs to address is connectivity, right?
Yeah. So thanks. Data connectivity, obviously, it's a very important point, the starting point. Once we have all the machines connected, we start collecting, receiving information, data. Data means not equally data. So there's big data versus smart data. How can we identify smart data from the big data?
Yeah, I think here you correctly identified one of the issues already, right? We find that the first step, there's this over-eagerness once we've connected a machine to want to record all the data and save all of the data in a data lake somewhere. And if one's not careful, and I think there's 2 things that one really needs to focus on. One is that if you just do this and you just send everything in, you really create a data swamp, right? There needs to be some sort of quality verification about what kind of data you're putting into it. And I think we'll go into it a little bit later on, also provide some more detail to our viewers on what the key challenges are there. But the other point that I want to make at this is really that if you're not use case specific when you're looking at what data to send up, right, then this happens very, very quickly, that you have sort of this huge collection of data that becomes difficult to manage and becomes difficult to actually identify how to use properly and effectively. Right?
So I have understood that data connectivity and big data, or classification of the big data versus smart data, is key in this process. But I'm wondering, what about the deployment or scalability of this solution?
That is then in the final step, right? So let's assume that we've got our connectivity and we've got good, clean data that we're collecting in an organized fashion. Now it becomes how do I actually deploy and scale what I actually am going to build. And I think on the right-hand side, the diagram that's shown there is what we typically find in industry. I mean, I think these figures also provided from one of the biggest companies involved in AI that we all know, Google. And they're essentially expressing the same thing that we feel we're seeing with our customers, which is AI is such a small component of the whole solution, right? And it's the first thing everyone focuses on. And the first thing companies do is set up huge data science departments, understand how they're going to resource, find and acquire the skills to run this department, and set up a whole chain of things so that they can actually start analyzing the data, but haven't considered anything else that goes around it. And we can see that's a considerable amount here, right? 96% of it, of the efforts of getting a use case working in production lie outside of developing the AI model. And if you're not considering right from the beginning what sort of strategy you're going to employ there and who's going to be responsible for this, and more importantly, how this technology is going to scale across your organization at a later stage, you run into a problem where your business cases at the end of the day don't scale either, right? It might work for your POC, but once you're trying to take that POC and run it over the whole organization and across multiple factories, suddenly there's a huge cost factor involved that had, up to that point actually remained hidden from what you were looking at. So, yeah, without data, we have no information, right? Jörg, we discussed the connectivity item first on the previous slide. I want to go a little bit more detailed into it. You have been involved with connecting machines, especially in the SMT area, for over 20 years. Maybe you can give us a little bit of a breakdown of some of these issues that you've seen, right?
Yeah. One of the key challenges is definitely supporting all these complex multi-vendor environment, especially in the factory environment. So it is, very challenging. All connecting to these machines, especially when there are different machines from different vendors with different communication protocols. Maybe there's vendor A that's using their proprietary protocol than vendor B, for example. So it's very complex providing a proper solution or maintaining all the solution with machine connection. So it's very key element here that there is a competent solution, a proven solution, which provides the ability connecting all these machines together in an omnidirectional perspective.
Yeah, earlier on you used such an interesting word to describe it. I think you called it the connectivity conundrum, right?
Yes.
That's really how do you keep all of these machines speaking to each other?
Right. Yeah.
So I mean, after that, I would imagine we get to the next problem. So say just we have gotten to the point where we have in our factory today all of our machines speaking to each other. Now, that's not where it stays, right? So what about the next step, which we have to think about? How do we add machines? How do we change machines? If we move something that we might have a use case working in one environment and we move it to another environment, what does that mean? And I think that is expressed really with the scalability and flexibility that we're talking about.
Yeah, right. So you have to be very reactive to these dynamic changes, especially when new machines will be installed or will be moved from one place or to another place. So you have to quickly adjust the configuration of the machine connection. And even with the connectivity itself, all the configuration that you have to apply needs to be very flexible in terms of new requirements. And I cannot tell even more that a proven and qualified solution is very key here.
Yeah. So if I heard essentially two key elements in what you were saying there. On the one hand, it's the speed of implementation that is important too, and I think also from a use case point of view, from my perspective, we know AI is moving quickly, and you want to be able to adjust quickly to getting new machines and new data available. And the other side that I also heard is the cost then, right? When it comes to changing things, reconfiguring things, also in terms of time, but also in terms of resources.
Right. Exactly. Yeah.
The last point that we've also highlighted or want to highlight here is then, I think, reliability and maintenance. So it's, I think, very easy to get lost in the problems we have to solve today. But what we're trying to suggest here is that it's not enough. One actually has to also look at where are we going in future, right? What I have running today, how can I ensure that? Because if it becomes a critical part of my infrastructure, I need to ensure that it's working possibly for the next 10, 15 years, right? How am I going to do that? And that is something where we have to shift into a future-orientated way of looking at the problem.
Right. So we will take all these consideration into the development, and reliability and maintenance is another key factor here that we have to support in terms of the machine connection. And it's something that you have
problem,
you don't have to underestimate it.
I've got some statistics here that we're going to look at. These are the different approaches that we are seeing, and I think again it's something that our experience is showing exactly the same sort of numbers in terms of the different approaches. Each strategy that we see on the slide actually has obviously certain advantages and disadvantages, but we're seeing generally these trends. And I think the first one is in-house engineering. That is very much about insourcing the skills that you need to be able to connect machines in the future, right, in your production. And that's something for me where I feel bigger organizations can do that, right? You can scale across the entire organization, but it still becomes challenging. The next options in the list are much more the reverse, and they're about insourcing, right?
Right, and this is the most.
Oh, sorry, I think I swapped those two around.
Yeah,
they're outsourcing.
One of the most interestingly bar here and figures is, or the percentage which is shown here, that a lot of companies relying on specialist partners, for example, MES experts, that can actually provide a field-proof solution for machine connectivity.
Yeah, so that's what I meant. So that would be like outsourcing, and you actually essentially looking at harnessing, I mean, MES companies, some of them have been around 20 plus years, insourcing those skills at providing their expertise at connecting equipment, right?
Right. Another similar percentage here is that out-of-the-box solution is also interested to use in the market.
Yeah.
So company very interested into the out-of-the-box solution which is available in the market.
But out of the box, okay, but that's also something that I think we're going to discuss in a little bit more detail too, and potentially even I think we prepared another short demonstration of what the solution can look like.
Yeah, we will see this later in the next slide. But another factor is which is considered when companies purchasing new equipment, that these equipment comes along with already available connectivity solution, which can be easy.
That would be protocols like OPC UA and CAMX and
CFX, for example. Yeah.
Okay. So like we mentioned, there's advantages and disadvantages with each of these strategies. We've essentially highlighted 3 dimensions in this diagram just to show you. I mean, this is obviously a complex problem, but this I think gives a good overview. The first dimension is very much the speed of implementation. We mentioned it before. How quickly can you implement and connect a new machine? The second one is the actual cost of implementation. At this point, we also have the bubble size, which represents the amount of data, the data richness that we're looking at, right? So we can see here, for example, purchasing new equipment is quite far out. So it says that it takes longer, right? And that's because you can't just go out and replace all of the equipment you have in your production facility immediately. Rather, you have to do that over 2 or 3 years. And even then, we can see by the size of the bubble, you're not guaranteed that you're going to get the data richness that you need when you actually trying to implement AI use cases then. The next one is the in-house engineering. Like I say, we said it depends on the size of the company, but that obviously can work out much more expensive. And also depending on the skill levels and how long the engineering team has been working on it, you might also be limited to what data you can have access to. Right? Much more data is available essentially from the experts, which would be outsourcing it to MES partners or vendors and having them do the integration part for you, right? But I think the final option is potentially the most interesting one for today, which is the modular approach. Perhaps you can tell us a little bit more about that.
Yeah, this is an interesting approach here, using modular approach, using adapters available from suppliers like MES experts or out-of-the-box solutions, which is based on a significant years of experience in setting up these modular adapters. And what does it mean? We will see this in a recorded demonstration.
So Jörg, we were just talking about this modular approach. So I imagine for some of our viewers, it's a bit difficult to imagine what we mean by this. Do you maybe have an example that you can show what this actually would look like in software?
Yes, as we all know, the main challenge is to connect all the SMT equipment, all your machines to one system. And thanks to iTAC SMT Edge, it provides a connectivity platform. We just demonstrated it. We just need to log in, and then we can access an existing communication system where we can see all connected machines with the corresponding adapter.
So that means if I want to add a new piece of equipment, I've just bought a new machine, all I have to do is come here and click on look for the appropriate adapter, configure it possibly, and I've already got my communication established on which I can build my new use cases or get my old use cases running.
Yes, it is very simple. Within a few mouse clicks, I can simply add a new machine, and thanks to predefined adapter, which is available and pre-implemented in that system, I can search for my proper adapter from the drop-down list, and I just need to find it, select it, and then I will be guided through the installation, a kind of an installation wizard to add the required base parameters to deploy the adapter and connect the required machine. Yeah.
So in the first use case, we discussed an AOI. In this case, we would be able to implement it using this adapter. But also, I think more importantly, if I now taking this use case from plant 1 and I want to implement it in plant 2, all I have to do is, and it might be different equipment running actually underneath, all I have to do is then come and reconfigure the adapter at the bottom, on the bottom layer, and not actually have to rework the whole use case.
Yeah, you can either reconfigure the adapter, you can actually also export the configuration and apply it to the new installation of the other factory. Yes.
So, yeah, then it leads us to the next problem, right? We see now that we have connected all of our machines, and then we find the typical next response, and we've mentioned it earlier, is to actually want to record everything, right? We want to show that we've got all this data, let's send it all to the data lake and see what we can do with it later on. And if we do it this way, we've understood in the meantime that brings so many new challenges with it that one must evaluate if that's really what one wants to do. Maybe the first one, big data is expensive. I think you have some statistics there for us, right?
Yeah. So especially hosting and storing the data, let's take our cell phone in example.
Yeah.
So everyone uses a smartphone, transmits data to an internet provider, and the cost of the data transmission is actually owned by the end user actually. So that is an interesting business concept by that companies. But what does it mean in the manufacturing environment? So companies are in charge in
for sending that data,
providing
in this case,
that
right?
investment to store all the data that is transmitted from the machine. Yeah.
Yeah, so I know that when you're talking about a plant, we're talking about terabytes of data per day, and I think that's what you were referring to. If we reference that to maybe the couple of megabytes that all of our companies are collecting of our data anonymously, and then still having the cheek of actually getting us to pay for the transmission in a plant that has what is that, a scaling factor of about 1 million, that you actually need to just sort of understand how different the problem actually is, right?
Right. Yeah. But Martin, what about the data quality itself and the results? So I can easily imagine that once you have receiving all the data in terabyte size, then it can be easily the case that you can also receive poor data.
That is exactly the question. So if we've understood that data is difficult and expensive to transmit, the first thing you ask is what I'm transmitting actually of the right quality? So in the first step, we need to look at how do we do inline verification within your event stream to actually make sure that that data is qualified, can be used, is of the right quality. Then only it makes sense to transmit it to the cloud. And the second thing is also then actually just to say there's this thing called data imbalance. And I think for those of us in Germany, I'm just going to name this as an example, but I think people might not completely agree with the statistics, but something like the infrastructure of the Deutsche Bahn runs at 99.99%, right? And if we actually interested in developing a predictive maintenance use case, that 99% of the data is really not interesting. You know, it's consistent. There's nothing interesting in it. We're really interested in the 0.001% of the data. And there I think it's very important actually to consider how do we actually get this data and how do we understand that context so that we can harness that before we send it to the cloud, right? Because that's really the data we're interested in.
Yep.
And that's where I feel, and I think my experience has shown that one has to then fall back to use case based approaches to collecting data. We'll discuss it we've got a 5-step program. We'll discuss it as one of the steps, but one actually has to say, how do I take a use case and build up the data that I need instead of actually looking for the data that I want later on. And finally, I think also just looking at the dependency that we have on the cloud these days. We understand the cloud scales well. That's where we can do the models and the training well. But where it doesn't work is if we're sitting back in our production environment and we have huge latency periods. It doesn't help. I need a response within 200 or 300 milliseconds, and it's taking me 7 or 8 seconds to get a response from my model in the cloud. So how does that what solutions are there that we can actually offer real-time processing of data on the shop floor?
Martin, you just mentioned the 5 steps in process data into smart data. So AI requires a smart data mindset, which we defined in 5 steps: defining the process, enrich the data, reducing the dimensionality, apply the AI, and implement the modules.
Yeah, correct. I think defining the process, there's a good anecdote that you have, right?
Right. There is an interesting anecdote. So it's called the street light effect. It's kind of a funny story. A drunken man is searching for his keys. So he thinks that he lost his keys around there, and so after a time, a policeman came by and asked the man, "Hey, what you are searching for?" "So I'm searching for my keys." "And are you sure that you lost your keys here?" "No." "So where do you lost them then?" "Maybe in the forest." "Yeah, why you are not looking into the forest?" Because the light is always clear, so it helps me to searching the keys." So what does it mean? So sometimes it's not obvious that we search for something that it's bright and we have the light there, but maybe it's better to take the lights and searching in
take a torch with to the forest
and taking it to the forest.
I like this analogy. I think specifically for me also what it really shows is if you often people connect machines, right? That is the street light, and then within that data they actually go looking for use cases. That doesn't work. We have to start with the key competencies of your company. You have to start with your value stream analysis and understand your pain points. And I think when it comes to defining the process, companies forget that actually they hear the word AI and they forget everything they've done in the past. There's an important thing to remember. If you understand where your value add is, right? You've been producing your products for a number of years, and essentially what people are paying for is your expertise at producing those products. Don't throw all of that away. The key thing is to take that, start with that, build up from that, look for the required data that you need to actually, and transfer all of that into a good AI model that you can actually, take your company to the next step.
Yeah, interesting. Yeah. The next step is what we just mentioned is enriching the data. So here's another example that would like to talk about is, so we are sitting in our car riding at 80 kilometers per hour. So at first it doesn't mean anything, right? So riding a car at 80 kilometers per hour doesn't mean anything. But once you say that you're riding the car at 80 kilometers per hour on the road, that means something. But once you say, okay, I'm driving my car at 80 kilometers per hour in a city. So this is totally different story, right? So Martin, maybe you can give us an example.
Well, I think you're talking about context, right? And the contextualization of information there, right? I can talk a little bit out of my own experience in production steering, right? Context is what you need when the manager phones you and says, "Why is my line not running?" or "Why is my first pass yield on that line so bad?" That's when you're like, "Oh, it's because of this and this, and maybe that machine was causing that." That's the context you're providing. And that, for me, is exactly why we feel also an MES is such a big multiplier when it comes to understanding context in the production environment. Essentially, number one, it offers you that traceability throughout your whole process so that you can link structured and unstructured data at each step and also link upstream and downstream processes. And on the other hand, you can also then just make sure that you can get the correct quality of data, as we've mentioned, but also that you can link all of that context back and even attach the correct labels immediately to your data when you're processing it. And that is of extreme huge amount of value, being able to do that in real time before you actually send anything or before you actually analyze anything.
Yeah, right. So another step that we defined in implementing AI solution is reducing the dimensionality. So having all the data in different dimensionalities and in different directions. So I can guess that AI requires flattening the data. Is that correct?
That is correct, right? So I think it's Mr. Feynman, Richard Feynman, who said if you can't actually simplify the problem, you haven't understood it yet. It is a bit of an oversimplification maybe when it comes to your data, but what one needs to do is understand what data is valuable and then see how you can actually package that data efficiently for your use case. And if you don't consider this, and we're moving slightly into the implementation area here, right? How do I implement it now? Going from a theoretical exercise of collecting data to actually implementing them on a production line. But if you don't consider that, then you're going to have trouble later on making sure that you can execute those models in real time with your required cycle times or throughput times that you have. And that's why we feel it's so important. So then the points that we've named here addresses the previous issues too, but you can do all of this. You need to be able to have some sort of event stream engine where you can process this data in real time, check its validity, check that for data imbalances, and then also reduce the dimensionality all in one go. So
yeah, thanks, Martin. Very interesting to hear that point. So let's have a look to the survey results, right? So I'm wondering, what about the survey results of our question that we mentioned in the beginning? Have you already started with the IoT journey in your factory? And there's interesting figures here. So
that is interesting, Jörg. So not completely unexpected. I'm a little bit surprised that quite a number of companies actually haven't started a journey yet. So we slightly different to maybe the graph I showed at the beginning, but I think if everyone's here, they've realized the importance of artificial intelligence and must be looking for the starting point. But other than that, we're looking at that most people have the use cases running in limited production, right? Very much there again, what we saw earlier today. There's a huge difference between actually taking it from limited to production in widespread production.
Yeah. So thank you very much for providing us the feedback.
Yeah. We did introduce that survey maybe just before the last step, which is actually the implementation part, because here we go a little bit more into the roadmap and the best, feasible options one has at actually implementing use cases. To name a few, on the right-hand side, we've actually just tried to classify the types of use cases that we've identified over the last couple of years. The first one sort of being the quick off-the-shelf use cases, right, where we know that we have quick return on investment, but we also know that the ease of implementation is quite easy compared to the more complicated ones. And that's normally a good place for most companies to start. Why? Because if we see also in the roadmap that we've painted on the left-hand side, you might not have the maturity level in terms of digitization, understanding AI, data science department in your organization. Therefore, it's a good place to start because you immediately get an impact and a feeling of what kind of benefits you can obtain from using AI in your environment, right? So off-the-shelf use cases are a good place to start. Once you've done that, then we see moving to operations-based use cases as the next step. Here we're talking about actually involving people on the shop floor, maybe your process engineers or your operators with use cases. And there we'll see it's a completely different value game there. One is looking at trying to make it as easy as possible for these gentlemen or ladies to actually implement artificial intelligence to different use cases. And then obviously the final goal, which in most organizations is to actually implement strategically important use cases that requires the highest level of digital maturity in your organization, meaning you need good skills and a good data science department normally to be able to help you convert what you currently have as process knowledge into artificial intelligence knowledge for your production line in future. But we call these the strategically important use cases.
Yeah, Martin, you just mentioned all these different use cases and with different approaches. So what does it mean exactly off-the-shelf use case?
Off-the-shelf use case, right? I guess there's, you know, you don't have to reinvent the wheel, right? Right. I think there's also a German expression which is everybody cooks with water, right? Yeah, we're talking about use what's already available. Start there, right? Everybody is facing the same challenges in production, and if you can actually acquire that use case or implement it quickly and effectively, then do that. That also maximizes your impact, gets you that management buy-in in terms of AI right from the start, and you have a much easier transition to the next stages that we just showed, right? Important when we talk about infrastructure, just on the left-hand side, again, the connectivity, but I mean, that's for all of the use cases. You need to be able to connect to the machines for the use cases to work. But in this case, you need an engine that allows you to implement multiple use cases without creating a new silo problem. In other words, the use case silo problem, where you have individual use cases standing around on different equipment, on different platforms, and somebody has to try and maintain that at the end of the day, because then you're exactly back in that situation where you have a whole bunch of systems, all of them are suddenly production critical, but nobody knows who's actually responsible for which one and how you're actually going to maintain these and how the long-term plan of all of these use cases look like. And that often prevents companies from taking that final step and saying, okay, let's go from one use case to the whole organization, widespread use.
Okay, thank you. Yeah, I understand that part. Yeah, but most interestingly, what about the operation-based use cases? Maybe you can also provide an example on
operations-based
the
use
experience.
cases, again, in the digitization journey is the next step, right? So we have management buy-in now. Now we want to introduce operators and process engineers to the tools, show them how this can make their lives easier. We might not have the full skill level, but we're finding operators and process engineers already are quite clued up on how AI can be used. But what they need is a platform that is simple to use, easy to use, where they can plug in. We have the connectivity at the bottom, but they can draw and drag and create their own workflows with algorithms available to them to maybe, for example, do anomaly detection on temperature, so that if it spikes somewhere, they get an alarm or their maintenance teams get alerted. Their GUI and the usability and the interfaces that you have are a key to actually successfully implementing this phase.
And the strategic important use cases, what about these?
That is potentially, obviously, the one that requires the most maturity. Here, I would emphasize the fact that you want to use the latest tools. The latest tools are all made by all the big companies that we know, the Googles, the Amazons, the Facebooks of the world, Microsoft. They're providing us with the latest algorithms, the latest tools, the best way of actually analyzing the data. We need to harness that. We never, as an organization, or as a production facility, going to try and compete with what these, these big organizations are doing in terms of the millions and millions of dollars that they're investing into developing new algorithms. But we want to harness that. So let's use their cloud platform, get access to those tools. The problem is, though, with that, right, the latency that we were talking about earlier. How do I bring that back into my production facility and make sure that I can implement that in the cycle time that I require, with the latency requirements? Some use cases that I know require a response within 40 milliseconds, right? If you're going to the cloud and then coming back, you can't do that. So you need to have an edge solution for those kind of use cases. And there we see two key elements to consider with your platform. The one is you need to be able to stream that flat data structure, those use cases that we had talking about, to the cloud, because in the cloud you want to train the model, so you need some sort of adapter to actually send the data there. And on the other hand, once you've trained the models, you need some sort of management tool to say, okay, how am I going to deploy it to all of my different sites all around the world and make sure that I'm, running the right versions, the latest version, and that I can control who uses what and how these are used in my organization itself.
Yeah, thank you very much. Yeah, Thank you, Martin.
So, Jörg, I think that brings us to the end of our presentation. We're going to now go back to some questions at this point.
Yeah, I think we have reached the Q&A session, right? So let's have a look what questions our users and viewers have entered. So
can I define my own use cases is one question. So obviously, I think we've shown that with the tools, especially if we're in that using the tools available for operators, it's very easy to define your own use cases. typically we have constructed most of our systems to actually have a low-code environment or a no-code environment where you can drag and drop the use cases and just click which algorithm you want to use. So operators and process engineers can, within a couple of minutes, set up their own use cases and change them as required.
So there's another question. I think that question is for me. So Mr. Boat spoke about the complex multi-vendor environment. I'm having multiple vendors per type of machine. How iTAC is ensuring communication with all these machines? So luckily and fortunately, we have one of the biggest machine connection library in the market. So we support more than 180 different machine types, I think. More to come, of course. And so we've been working on these machine connectivity library for many, many years, and we keep continuing increasing and expanding that library.
Yeah, and also they tried and tested with the different use cases, right? So we have that reassurance too that we're collecting and harnessing the right data.
Yeah. So another question, I think that question is for you, Martin. Can the trained model be deployed across multiple factories?
Yeah, I think so. Yeah, I did touch on that one. So if we have, if your platform has a tool for centralized model management, that is normally the best way. That allows you to actually decide which version is deployed, who can use which version, when it is implemented. It can automatically be updated. You can control all of those things centrally from a centralized platform. That, of course, helps if you have centralized your data science department. Then you can actually have one person or one organization responsible for your complete, algorithm. What would you call it? Ecosphere in your environment or in your organization, and it allows, a centralized, managed approach to it.
Thank you. I think the next question is also for you, Martin. So you mentioned that scaling the AI models globally is a big challenge and that you need to make sure that you do it right from the beginning. How do you make sure that you do it right?
Yeah, it's a good question. It's essentially the quintessence of what we're trying to say today. I think a whole presentation is based very much at answering that question, but I think if I had to highlight a couple of things again, right, the flat data structure with event streaming, I think, is often forgotten or not included in the beginning, and then you run into performance calculations later on. The other one is deciding on if you're going to how you're going to use the cloud and how you're going to use what tools to actually deploy the models, and deciding again how you're going to centralize the feedback cycle and deploying those back into your production environment. We've seen obviously certain use cases do work. So, I mean, if you have certain use cases and you have a longer latency possibilities, you can do a complete cloud-based solution. But as soon as you're talking about production, where we need speed and we need reactivity and we need to look at hybrid solutions, and we need to actually understand how we implement what we developed in the cloud locally.
Yep. Good. Thank you. And maybe the last question for today. Of course, we have a lot of other questions, but this is, I guess, an interesting one. All machine vendors have visualization tools for real-time and deep dive analysis. Why are your tools different?
There again, I think one needs to, it's all about context, right? We discussed about how the MES links everything together. If you have a single machine that only looks at the data of one machine, you're isolated, you've got a silo going again. It might give you, in the first step, very good results to actually look at that. But in the longer term, you might have much more value by linking that again to other systems and understanding what your downstream information and your upstream information is telling you about your process at that point too. So it's not a bad point to start, but obviously you can gain so much more, and you have this multiplication effect if you start including other data sources.
Okay. Yeah, thank you, Martin.
So for those questions that we haven't managed to answer, we will also take the time afterwards just to get back to our viewers. We'll summarize them, make them available. And at this point, I think all that's left to do is actually thank our viewers for joining us. And Jörg, thank you for your input.
Yeah, thank you, Martin. Thank you, and have a good day. Thank you.
Thank you.